Hello students, this is my fifth class with you, and today we shall see solution of nonlinear PDE of first order in some special form. There are four forms, one form already done in the last class, and today we shall see three more forms. Form number 2, f of z comma p comma q equal to 0. F is a function of z p q 0, that is the PD is just containing z p and q only, x and y directly not involved. Therefore partial derivative of this f with respect to x and with respect to y, that is fx and fy, are both 0. Therefore Chaput's auxiliary equations gives dx by minus fp, dy by minus fq, dz by minus pfp minus qfq, dp by f suffix x, fx plus p fz equal to dq by fy plus q fz. Now here f suffix x, f suffix y are both 0. Partial derivative of f with respect to x and y are both 0. So this last two becomes dp by p fz equal to dq by q fz, and then fz cancels because fz is arbitrary. So what we get, dp by p equal to dq by q we have written. Therefore dp by p equal to dq by q. Therefore integrate both sides, and constant of integration we can add to the left side or to the right side, no matter. We have added log a, constant of integration. A is arbitrary constant, so that it becomes log p plus log a, that is log a p equal to log q, that is q equal to a p. If you add to the right side, it will be p equal to a q. Finally answer will be same, just adjusting arbitrary constant. So q equal to a p. Now dz is p dx plus q dy that is q value is a p, so p common, dx plus a dy, but dx plus a dy can be written as d of x plus ay, d of x plus ay, that is d of u, let us write, where u is x plus ay. So this line gives dz by du equal to p, and q equal to ap, means a dz by du. Therefore our PD f of z comma p comma q equal to 0 becomes f of z comma dz by du comma a dz by du equal to 0. This is an ordinary differential equation of first order in z and u. Z is dependent variable, u is independent variable, and can be sorry, and can be solved to obtain z as a function of u, and then replacing u by x plus ay, already we get the complete integral of the original PDE. Now let us solve some problems on this form. Example number 12. In continuation, we have given the number. Find complete integral of z equal to p square plus q square. Nonlinear, first order. So this PDE is first order nonlinear and is of the form f of z comma p comma q equal to z minus p square minus q square 0. You can write p square minus z 0, no matter. I have written like that. So this is number 1 given PD. Now it is of the form number 2, f of z comma p comma q 0. So we take u equal to x plus ay, a is arbitrary constant, and get p equal to dz by du, q equal to ap, means a dz by du, already we have seen in the theory. Therefore this PD becomes z minus dz by du square, p square minus s square q square, means s square p square, q square means s square p square, p square is again dz by du square. So side changing, taking common, z equal to 1 plus s square dz by du square. So taking root, plus minus root z is root over 1 plus s square dz by du. Then separating the variables, du equal to root over 1 plus s square by z dz will be in the numerator. So it is with plus minus, and we have taken. Then give 1 2 adjusted here, so that integration dz by 2 root z is root z readily. So we have adjusted these two and then integrated both sides. And constant of integration is b, this time we have added to the right side. So it is dz by 2 root z, integration is root z. Then square both sides, we get 4 1 plus s square z equal to x plus ayy, because u is x plus ay, and plus b whole thing square. So this is our required complete integral of the given PD. Example number 13. Find a complete integral of the PD z square equal to 1 plus p square plus q square. So this is also of first order nonlinear, and it is of the form f of z pq equal to 0. This time what I have done, z square is taken to the right side. Previous one we have taken these things to the left side. This time we have taken z square to the right side. No matter, both way can be done. So this is our PD in the form number 2. So u will be x plus ay, p will be dz by du, q will be ap means a dz by du. Therefore number 1 becomes, putting the values of this p and q. Yes, of course, before putting we have simplified. Number 1 becomes this p square common 1 plus s square equal to z square minus 1. Then root over taken plus minus p root over 1 plus s square root over z square minus 1. Then p means dz by du, and then separating the variables dz by root over z square minus 1, and integration also given in at the same time. Du will be here, so integration du plus b, new arbitrary constant of integration. Now dz by root over z square minus 1 we have written cos hyperbolic inverse z, standard integral. Dx by root over x square minus 1 is cos hyperbolic inverse x, or it is log x plus root over x square minus 1. This we have got in class 12, log x plus root over x square minus 1, but this can be also written as cos hyperbolic inverse x. So here we have written cos hyperbolic inverse z. Answer will be in nice form. Now taking this plus minus root over 1 plus s square to the right, that is in the denominator, and then it will be cos hyperbolic inverse z is that, means cos hyperbolic inverse when goes to the right it will become cos hyperbolic. So z is equal to cos hyperbolic u plus b by root plus minus root over 1 plus s square, that is equal to cos hyperbolic u plus b by root over 1 plus s square. Why? Because cos hyperbolic minus x is cos hyperbolic x, same like cos minus theta is cos theta, like that. So our solution is z equal to cos hyperbolic x plus ay, because u is x plus ay plus b by root over 1 plus s square. This is our complete integral where a and b are arbitrary constants. You can give the answer in terms of log, no matter. You can write it is log z plus root over z square minus 1, answer can be kept. Number 14, homework. Find a complete integral of this PDE. Answer is given. You will do similar to previous one. Number 15, find complete and singular solution of this. Complete solution, singular solution means complete integral, singular integral. Here the word integral and solution synonymous in case of differential equation. So given PD is of the form, see z p cube present. So it is of the form 2. 4 into 1 plus z cube minus 9z to the power 4 p cube equal to 0. So let u equal to x plus ay, then p is dz by du, q is ap means a dz by du. Now this p and q, pq will be a dz by du square. See, we have substituted the values of p and q in number 1 and got this. Now side change. dz by du square is 4 1 plus z cube by 9z to the power 4a, then dz by du is plus minus root over this 2 root over, and 9 means 3 and root a, and z to the power 4 will become z square. Then du taken there 2 du, and these things taken with dz, so plus minus 3 root a z square numerator and root over 1 plus z cube denominator. And then t square is equal to 1 plus z cube is substituted. So left side derivative is twice t, means twice t dt we shall write, and the right side it will be 3z square dz. Then it becomes 3z square dz is dt. So 2 root a dt, this is 2t dt. So it will be 2 root a t dt, and denominator is t square is that, so it is t. So 2 cancels, and then integrating constant we have added to the left side. Integration du plus b means u plus b, and right side is dt integration is t. And then if we square, u plus b square is a t square plus minus gone. T square is 1 plus z cube, already we have substituted there. And then value of u is x plus ay substituted. So this is our complete integral, x plus ay plus b whole thing square minus a 1 plus z cube equal to 0. Complete integral. Here a and b are arbitrary constants. Now we have to find singular integral or singular solution. Differentiating this number 2, complete integral, partially with respect to a and with respect to b. It is in the theory. How to find singular integral or singular solution? We have to differentiate with respect to the arbitrary constants. Means this expression we are considering as a function of a and b. X, y, z will be constant when we differentiate with respect to a and differentiate with respect to b. So if we differentiate with respect to a, it will be twice x plus ay plus b into derivative of this with respect to a means y. So it is there. And here with respect to a means it is only 1 plus z cube with a minus sign. So number 3. And if we differentiate it with respect to b, we get twice x plus ay plus b into 1 means b derivative is 1. So it is that only. And here no b, so 0. Now number 4. Now this value if we put here in number 3, we get minus 1 plus z cube 0 means 1 plus z cube is 0. Number 5. Now if this line is differentiated, number 5, with respect to x and y partially, we get 3z squared del z by del x 0, 3z squared del z by del y 0. Means del z by del x, del z by del y both 0 because z is arbitrary. So p0 and q0. Now this p0, q0 together with 1 plus z cube equal to 0. Number 5, we see that the equation number PDE number 1 is satisfied. You can check. This is number 1. P0, Q0, this part 0, and 1 plus Z cube, this part 0 minus 0 equal to 0. So equation is PD is satisfied. 1 plus Z cube equal to 0 satisfies the PD number 1 without any arbitrary constant. And also this cannot be obtained from general complete integral by giving particular values to A and B. That's why it is singular integral or singular solution. So 1 plus Z cube 0 is the required singular solution or singular integral. So this way we find singular integral. In any other question also it may be asked. Of course, some PDE may not possess singular integral. Example number 16, homework. Find complete and singular integral of this PDE. Answers given. Singular integral here incidentally Z0. Z0 means P0 and Q0. So if P0, Q0 and Z0 is satisfied, but Z0 how obtained we shall see in the solution. You will see in the solution by this process. Okay, this is about form 2. Now we go to form number 3. It is f1 xp equal to f2 yq. That means equations in which z is absent, directly z absent, and the terms containing x and p can be separated from those containing y and q. Terms containing x and p in one side, terms containing y and q in another side, means separable equation, you can say, separated. In this case, the PD is f of xyz pq equal to f1 xp minus f2 yq equal to 0. If we set change. Therefore, Charpit's auxiliary equations gives del f by dx by del minus del f by del p, dy by minus del f by del q, dz by minus p del f by del p minus q del f by del q equal to dp by del f by del x plus p del f by del z equal to dq by del f by del y plus q del f by del z. These are standard expressions you have to remember. Now here incidentally del f by del p is del f1 by del p. There is no p. So it is minus del f1 by del p. Del f by del q is, this is f, here no q, so 0. It will be minus del f2 by del q. See, it is plus del f2 by del q because there is minus sign. So, and this term dz by is just this multiplied by p, that multiplied by q and added, we get this. So directly written. And dp by del f by del x means it will be del f1 by del x, and del f by del z, there is no z0, so it is minus only del f1 by del x. Del dq by del f by del y means it will be, there is no y, so it will be minus del f2 by del y, and del f by del z is not there, 0, so minus del f2 by del y. Now considering first and fourth ratio, we get first and fourth dx by minus del f1 del p, dp by del f1 by del x. Why we have considered? Because we can separate the variables and you can integrate. Of course, you can consider also second and last one also can be considered. So considering first and fourth ratio, we get, if we multiply across, del f1 by del x into dx equal to minus del f1 by del p into dp, and side change means it will be plus equal to 0. But incidentally, this is total differential of f1. f1 is a function of x and p, so this is df1 equal to 0. Means integrating, we get f1 equal to constant, asa, an arbitrary constant, that is, you can say f1 xp equal to a. Now if we put f1 xp equal to a in number 1, f1 xp equal to a, so a minus f2 fyq equal to 0 means f2 yq also a. So considering second and last, we shall get f2yqa, but directly here we have got also. So f1xp equal to a number 2 and f2yq equal to a number 3. Now if we solve this for p and q, surely we shall get value of p in terms of a and x, value of q in terms of a and y. So we have written p equal to f1 capital F1 xa and q equal to capital F2 ya. These are new expressions involving y and a, here involving x and a. So values of p and q are obtained in terms of x and a and y and a respectively. Therefore dz becomes p dx plus q dy equal to f1 xa dx plus f2 ya dy. This can be integrated. Therefore integration we get z equal to integration of f1 xa dx plus integration of f2 ya dy plus b, which gives complete integral. So this is the process in form 3. Let us solve some problems. Sorry. Number 17. Find a complete integral of p square minus q square equal to x minus y. See this equation. We can side change and write p square minus x equal to q square minus y. That is functions of x and p in the left side, functions of y and q in the right side, separated. So this equation is of the form f1 xp equal to f2 yq. Here f1 xp, in the theory we have seen f1 xp is a, f2 yq is also a, arbitrary constant. So p square minus x equal to a and q square minus y equal to a. From this, p square equal to x plus a, q square equal to y plus a, and p is plus minus root over x plus a, q is plus minus root over y plus a. Therefore dz is p dx plus q dy. So values of p and q substituted and then integrated, and the integration is, it is actually x plus a to the power half. So half plus 1 divided by half plus 1, that is 3 by 2, and divided by 3 by 2 means multiplied by 2 by 3. Here also same thing, power 3 by 2 multiplied by 2 by 3, and integrating constant plus b. So which is a complete integral of given PD. Actually you can take both with plus sign, you can take both with minus sign, you can take plus minus minus plus. So there are many complete integrals. In PD it happens. That's why question sometimes asked, find a PD, find a complete integral of this. So a means anyone, so you can give all or you can give anyone with plus sign or minus sign, like that. So number 18, find a complete integral of root p plus root q equal to x plus y. It is similar to previous one. You will do answer is also given. 19, find a complete integral of yp plus xq equal to plus pq equal to 0. This is of another form, but still we can convert it to the form number whatever done here, form number 3. This number 19 is we shall get later. Okay, PD is yp plus xq plus pq equal to 0. Okay, it is not in form 3 directly, we can convert it to form 3. Let us see. So divide both this by pq, what we get? Y by q plus x by p equal plus 1 equal to 0. So if we take here x by p plus 1 in one side, means x plus p by p, and y by q right side minus y by q. So this is function of x and p, this is function of y and q. Yes, which is of the form f1 xp equal to f2 yq, form 3. Therefore f1 xp equal to a and f2 yq equal to a. This is in our theory where a is an arbitrary constant. So x plus p by p equal to a and minus y by q equal to a. So here if we cross a p minus p, means a minus 1 p x value is, and y is minus q is minus y by a. So from this line p is x by a minus 1 and q is already we have got minus y by a. Therefore dz is p dx plus q dy, and value of p, value of q substituted and then integrated. It is x square by 2. Here it is also y square by 2. These are constants taken out, minus sign, and constant of integration we have written b by 2 only to write the answer in nice form. 2 will be crossed. So twice z is x square by a minus 1 minus y square by b plus b, which is required complete integral where a and b are arbitrary constants. So this is about form 3 examples, and now form 4. Z equal to px plus qy plus f of pq, function of p and q, any expression involving p and q. Here it is px plus qy, but in this equation it is py plus qx. Oh, this is not of form 4. It should be converted to form 3 we have done. Okay. So z is px plus qy plus f of pq. That is a first order PD analogous to the Clairaut's equation in ODE. We have got in first semester Clairaut's equation, ordinary differential equation. It is of the form y equal to px plus fp, where of course p was dy by dx, and the complete solution was just replacing p by c. We got y equal to cx plus f of c, like that. So this is also similar to Clairaut's equation in single variable. Here it is two variable. In some books also this is written as Clairaut's equation in two variables. Okay. In this case, the PD is px plus qy plus f of q minus z. This z we have taken to the right side, minus z equal to 0. So it is f of x, y, z, pq 0. Number 1. Chapit's auxiliary equations gives, as usual we have written standard results. Now what is del f by del p here? This is f. Del f by del p will be x. This is 0, and this will be del capital F by del p. So minus means minus x minus del f by del p. Similarly, del f by del q will be minus y minus del f capital F by del q, and then dz by multiply this by p, this by q, and then add. So directly we have written similar results, just multiplied by p and q. Then dp by del f by del x means it is p. Here p only, del f by del x will be p only, plus 0, and here it is del f by del x, no x, so 0, and here minus del z by del x, because z contains x. Z is a function of x and y, so del z by del x means p, so it is p minus p. And del f by del y also, here it is q, minus plus this is 0, this is 0. If we differentiate with respect to y, then here minus del z by del y means q, so see q, so q minus q. Therefore denominators of dp and dq are 0, means dp and dq are both 0. Therefore dp 0 and dq 0. Why 0? Earlier it was explained. It is not that like this, before putting the value we can cross. Say this value we can cross with anyone. We can cross with first one, and then this value is 0. 0 into dx by minus del f by del p 0, so dp 0, like that, dq 0. So therefore dp 0 and dq 0 means integrating we get p constant, q constant. So we have named a and b. A and b are arbitrary constant. Therefore complete integral of 1 is given by just putting the value of p and q in number 1, z equal to ax plus by plus f of ab. Just replacing pq by arbitrary constants a and b, we get the complete integral of a PDE in this form. In ordinary Clairaut's form equation also we have seen this form. Just replacing p by c or p by arbitrary constant, we get the solution. Here also we get complete integral, just replacing p and q by a and b. Very straight cut. And singular integral, if necessary, we shall find in some example. So example 20, find the complete integral of the PDE number 1 and number 2. Here log p plus log q, you can write log pq. And also find singular integrals. So let us solve number 1, number 2 will be homework. So given PDE is z equal to px plus qy minus 2 root pq, which is in standard form f of xyz pq equal to px plus qy plus capital F of pq equal to 0, like Clairaut's. So replacing p and q by arbitrary constants a and b in the given PDE, we get its complete integral as z equal to ax plus by minus 2 root ab. Just p by a, q by b. So it is complete integral. Good. Now we have to find singular integral. So differentiate this line by with respect to a and b partially. So differentiate this number 2 partially with respect to a and also with respect to b. We get here with respect to a means a and b are we are considering now variable and others are all constant. So 0 left side, z derivative will be 0. Ax with respect to a, if we differentiate, answer will be x. By no a, so 0, and then minus 2 remains, and root ab derivative will be 1 by 2 root ab into b, because we have differentiated with respect to a, so b constant, that's into b. Similarly with respect to b, if we differentiate left side, derivative of z is 0, ax will be 0, and by derivative with respect to b will be y, minus root ab will be 1 by 2 root ab into a, because this time we have differentiated with respect to b, a constant. So we get from this what? 2 cancels, b cancel, it will be root b by a, means x equal to root b by a. Similarly from this, y equal to root a by b. 4. Therefore 2 becomes, means values of x and y, if we put in number 2, what we get? A root a b by a plus b root a by b minus 2 root a b, that is root a b minus 2 root a b, that is 0, that is z0. Now z0 means del z by del x 0, del z by del y 0, so p and q are 0. Therefore p, q0, q0 and z0, if we put in original PD, p0, q0, z0, see, equation is satisfied. Therefore z equal to 0 is the singular solution, satisfied by z equal to 0, and hence it is a singular solution. Number 2, complete integral answer is given. You can write here it is log AB, just replacing x and y, p and q by a and b, and singular solution is z equal to minus 2 minus log xy. You will find similar to that, means differentiating this line with respect to a partially, with respect to b partially, and then proceeding as in Roman 1, you will get this. Number 21, prove that a complete integral of the PDE px plus qy minus z whole thing square equal to 1 plus p square plus q square is ax plus by plus cz equal to s square plus b square plus c square to the power of. Answer is given. But you see a, b, c, 3 arbitrary constants, looks like 3 arbitrary constants, but it is of having 2 independent variables. So let us see. Given PD is this, side the taking root over, we get plus minus root over this 1 plus p square plus c square. So z equal to set changing px plus qy plus minus root over 1 plus p square plus q square, number 1. So this is of the form 4, standard form, which is of the standard form z equal to px plus qy plus f of pq0. So complete integral is given by z equal to ax plus by plus minus root over 1 plus s square plus b square. Here integrating arbitrary constants, we have taken capital A and B. Capital A and B, small a and ABC will be coming later. So this is the complete integral. But in the answer there is no plus minus, so we shall take only plus sign and we shall adjust the arbitrary constants capital A and B. See, now to get a complete integral in desired form as given in the question, we take positive sign in number 2, here plus sign we shall take, and take capital A equal to a by c minus a by c, capital B equal to minus b by c. Then number 2 gives, this number 2 will become minus ax by c minus by by c plus, if we square, of course minus will not be there, s square by c square plus b square by c square, and then here c square to the power half means c will be there, so crossing c it is cz, and ax by will be side change, so ax plus by plus cz equal to s square plus b square plus c square whole thing to the power half. So solution is obtained, and some questions left as exercise you will solve, and these are the all forms, special forms 1 2 3 4, without using Chapitz. If the equation is given in special form, whatever we have done, then easily we can solve. Otherwise we have to solve with the Chapitz method. That is a difficult method, lengthy method, of course. So thank you for today.